This is A-level further math edexcel core pure 1 chapter 5 volumes of revolution. So let's go for the questions with the flag with P and E. So we start with number 5. This diagram shows the curve and the line, and A, the coordinate of the point A, which is intersection point. So here y equals 24 minus 3x over 4, and let's put it here. Then 24 minus 3x becomes x cubed plus 2x squared plus x. I just cancel the over 4 on both sides. So x cubed plus 2x squared plus 4x minus 24 equals 0. Let's find, maybe we can try the 2 here, then 2 to the power of 3, 2 and 2 to the power of 3, and 4 and 2, which is, we have 3, 8, which is 24 minus 24 equals 0. So one root is 2. So we now know that 2 is the x-coordinate of intersection point. So when we put it here, the number 2 in the x, then we find 18 over 4, which is 4.5. So now we make the revolution, like rotate through 2 pi radians about the x-axis, like here. So we can find the solid like this. So like this. So there are 2 different parts. This is not between 2 curves. This is just one curve, but 2 interval. Integral 0 to 2, like a pi y squared. So pi y squared dx plus pi 2 to this one, x-intercept when y equals 0, 8, 2 to 8, 24 minus 3x over 4 squared dx. You can find, you can do the integration easily. Number 6, diagram shows a cross-section of a circular golf ball trophy holder, okay. So this is the curved part is y equals 0.1 x squared plus 4. And it starts from negative 2 to 2. So we will rotate it 360 degrees about the y-axis, like here. So when we rotate it, we can guess the solid look like this. Like this. Actually, no, my drawing look like the cylinder, but no, it's like this. You know what I mean? So here is high and this is low, something like that. So anyway, use this model to find the volume of bronze needed to make the trophy. So limitation of this model. So integral, but because this is over y-axis, about the y-axis, so the formula is pi integral x squared dy. So x squared is y minus 4 over 0.1. And we need to understand the y, okay, this is a little bit different. So let's see. So from here to here, this is x equals 2. So integral 0 to, the y-intercept is 4. So 0 to 4 pi x squared, which is 2 squared dy. This is the rotation of this one, the volume of this part. Plus This one, actually this is between two curves. So pi integral 4 to, when x equals to 2, y is 4.4. So 4 to 4.4. The farther the radius is 2, so 2 squared minus the smaller radius is this one, so y minus 4 over 0.1. This is x squared, so we don't need to do something. So like this. This is the volume of this trophy. Or you can find the volume from 0 to 4.4, 2 squared dy, which is until here, everything, like here. And we can subtract this part, minus integral pi 4 to 4.4, y minus 4 over 0.1 dy, for example. So this gives us the same result, I think. So for the limitation of this model is because it's cast out of the solid bronze. But what we found from A is the volume of completion. So actually the bronze, we need more volume of bronze, more amount of bronze to start with. So maybe this can be the limitation of this one. Number 7, the diagram shows the outline of circular mushroom. The dimension, the diagram are in centimeters. The cap of the mushroom is modeled by, okay, so this part is this one. Mushroom formed by rotating the shape about the y-axis. So we can find from here 0 to 4, integral pi 0 to 4, x squared dy. So x squared is a squared to y minus 4y times 4. This is x squared from here. dy, this is the volume of this part, plus integral negative 4 to 0. This is x equals 1, so when we rotate it, pi x squared dy, you will find it. Number 8, the shaded region is bounded by the curve 360 about the y-axis again, exact volume. Yep. So we need to find the what is that? The intersection point first. So x squared is y over 2. So 3y squared plus y over 2 minus 11y becomes 0. So 6y squared plus y minus 22y equals 0. 6y squared minus 21y equals 0. So 3y, 2y minus 7. So this may be here, 7 over 2. So now we know. So this is between two curves. When we deal with the volume of between two curves, we need to understand which curve makes it larger, like largest solid, and which curve is like carved out. So here, when we rotate around like this, actually this part will make like this oval shape, the volume when it is rotated, and eventually we carved out this part. So integral 0 to 7 over 2 pi. So here the x squared again is 11y minus 3y squared dy, and minus pi over integral 0 to 7.2 x squared is y over 2 dy. So eventually, actually this one, because this is the same integration, so we can put them together, 0 to 7 over 2, 11y minus 3y squared minus y over 2 dy. So pi 0 to 7 over 2, This is 22, like a 21 over 2y minus 3y squared dy. You can integrate it. Okay, the last one, challenge. This is r with radius of 0,0. So x squared plus y squared becomes r squared. So show that the area of the shaded disk. So this is the radius. So y is radius. So pi y squared, this is the radius of the circle. So pi y squared is r squared minus x squared. That's how we find the number A. So number B, integral over the appropriate interval, show the volume of sphere. Oh, okay, so volume of the sphere. So we can think this part is rotated around about the x-axis. So integral negative r to r pi y squared, which is r squared minus x squared dx. So pi r squared x minus x cubed over 3 r to negative r pi r cubed minus r cubed over 3 minus negative r cubed plus r cubed over 3. So pi 4r cubed over 3. That's how we deduce this 4 over 3 pi r cubed. That's it.